Computer programs and cooking recipes are actually really similar when you think about it. They both specify a bunch of inputs, describe how to reach an output, and almost always end up going way worse than you would expect them to. Despite these similarities, however, if you actually look at them side by side, they couldn't look any more different. So, David Morgan Marr, also known as Danger Mouse, invented the Chef programming language. Chef is an esoteric programming language where the code you run resembles cooking recipes. Chef is designed so that, quote, program recipes should not only generate valid output, but be easy to prepare and delicious. Easy to prepare and delicious, of course, is completely subjective. Chef programs can take the form of recipes for any food item, ranging from fast food to ice cream to the food equivalent of lost faith in humanity. Which I guess would be deep-fried Kool-Aid. And yes, apparently that's a thing.
Wait a sec. How does one fry a liquid?
I think it would involve opening the gates of hell. But anyway, let's walk through how a chef program is written. Using tendies. A chef program starts by specifying the recipe's name and description, which do nothing! What follows is the first actual part of the program, the ingredients. An ingredient is specified by writing the default value of the ingredient, a unit, and the ingredient's name. Ingredients can either be dry or liquid. Units such as grams or kilograms denote dry ingredients, and units like cups or milliliters denote liquids. So, 1 kilogram of chicken declares a dry ingredient called chicken with a default value of 1. Similarly, 1 liter of water declares a liquid ingredient called water with a default value of 1. What follows is the cooking time and oven temperature, specified as minutes and degrees Celsius.
So, what do those values do anyway?
Absolutely nothing.
So, what's the point in having them if they don't accomplish anything?
I don't know. Anyway, up next is the part of the program where the actual calculations take place, the method of preparing the dish. So yes, this SOLang is just a gigantic metaphor for cooking. Ingredients in cooking are like variables in coding, and the methods in cooking are like the methods in coding, I guess. Anyway, first, the chicken and the bread are taken from the refrigerator, which is Chef's way of taking an input from the user as a number. The ingredient's value is then replaced with the input. So, if the user typed 5 and 6, chicken would hold the value of 5, and bread would hold the value of 6. Next, the chicken is put into one of our infinity mixing bowls, and the bread is added in. Adding the bread literally adds the bread's value to the value on top of the mixing bowl. So the mixing bowl now contains the sum of chicken and bread, so it pours that into one of our infinite baking dishes. The program concludes with specifying how many people the recipe can serve. In our case, we only serve 1. This final command takes that many baking dishes and reads them to the screen. So now we have an adding program. So the program works, but how good are the chicken tenders? Well, let's see what Gordon Ramsay thinks.
What is that?
I don't know, Chef!
It's not good enough! Get out! You're not good enough! Piss off!
Well, I guess easy to prepare and delicious was more of a suggestion than anything else.
Hey, I just wrote a new recipe for fish and chips. I think they'll be so good, everything you say will end with an exclamation point, because they're factorial in chips! Yay!
So, let's take a look at factorial in chips. Yay. Factorial in chips, unsurprisingly, computes the factorial of a given number. Factorial in chips really only needs 2 ingredients, fish and chips, but to add some realism, I put breading in there as well. But it's not going to be useful for anything and we can pretty much just ignore it. Fish is first taken in from the user as input, and chips, containing the value of 1, is put into the mixing bowl. What follows is a loop. Arbitrary verb, the insert ingredient here, will run a loop as long as the ingredient is not 0. Kinda like brainfuck's loop. Inside of this loop, fish is combined into the mixing bowl, which multiplies the contents of the mixing bowl by fish. Loops end with arbitrary verb ingredient until matching verbed, so this block is the bread loop. Specifying an ingredient here will cause the ingredient to decrement itself by 1 on each pass through the loop. So if we write down the product this will generate, we have a factorial. Now all we need to do is read it out. So let's see what the food critics think. I wouldn't do that. You know he's sensitive. Yeah, on second thought, let's not. Your fish and chips are probably wonderful creature-y.
Yay! Thanks for being so kind. I'm kind of an amateur. I still don't know a lot of things. For example, I know there's liquid and dry ingredients in Chef, but what are the differences between them?
What a convenient time to ask. I was just about to hand in a letter to the boss about that very topic. Oh, no, you're not. Using my new letter obfuscator, I'm going to obfuscate it. Man, isn't that text so much nicer now? I believe so. I hate you. But my boss saw you do that. He's right over there. You idiot! Fix that text now! It's important! Ow, ow, can't you just appreciate the obfuscated text for what it is? No! Fix it now! Fine, if you stop jumping on me like this. I actually carry around the recipe for de-obfuscation water, just in case. I'm gonna go prepare some now. So here we have ASCII to string water. The ingredients are, unsurprisingly, water. And just water because it's water. Water is a liquid since it's measured in liters, which means it will output its values as ASCII characters rather than numbers. So this program loops in, reading all of our input and puts them into a liquid ingredient, converting the ASCII codes to actual ASCII characters and terminating at 0 because that's the way loops work. And so this program converts an ASCII code message back into a string. Pretty cool, huh? Well, is there any reason that I need to stir this water for the equivalent of 16.5 hours? Man, this is why de-obfuscation sucks. It's so quick and fun to obfuscate things, and so tedious and slow to unobfuscate them. Well, the items in the mixing bowl are actually on a stack, which is a data structure that behaves kind of like a stack of pancakes. Pretty fitting, huh? You put things on top of the stack, and the first thing you remove was the last thing placed on top. When a dish is served, the stack takes the items off, starting with the last one put in. So if we didn't stir, the message would be printed backwards, and we don't want that. Stirring a mixing bowl buries the top value of the stack the number of minutes down. Since we use 999 minutes here, it will pretty much always put the latest value on top of the stack at the bottom of the stack, which makes it so that instead of adding values to the top every time, we're adding values to the bottom every time. And so it's printed out forwards now. Finally done with this stupid recipe. I need to sleep. Well, let's just apply this water and get this over with. You know, in all fairness, I could have just retyped that. Well, now it's wet! Go fix it! And because of your bad performance, you're not getting paid this week, idiot!
Hey, welcome to the club, Carl!
Don't rub it in, dude. Anyway, if you want to try out Chef yourself, a link to tio.run, where I used it, is in the description. Thanks for watching, and I'll see you next time!